All right, grade 11s, we have really the second half of our power rules, two more rules that you may not be as familiar with that we are responsible to understand. So it will be short today, but it's a little new. First power rule that you haven't seen likely is a negative exponent. So 5 to the negative 3. The negative exponent means to flip 1 over. And now that I've dealt with my negative exponent, 1 over 5 cubed. This is actually a 1 cubed as well. I have flipped it and cubed it. I will have 1 over 125. If you want to know why, I will show you the pattern. If you have something like 10 squared, 10 to the first, 10 to the 0, 10 to the minus 1, and so on, you will see the pattern. 100. One less power would be 10, so I'm dividing by 10 as I go down. 1, 1/10, there's our flip. 10 to the minus 2 would be flip and square 1 over 100. So from the patterning, that's where it comes from. So if I have 2/5 to the minus 4, my negative exponent tells me to flip. And then I still have the exponent positive 4. 5 to the 4th is 625. 2 to the 4th is 16. Final answer. So for negative exponents, flip. Let's try a few. 3 to the minus 4, 1 over 3 to the 4th, which is 1 over 81. B, minus 2 to the minus 3. So I have a negative exponent, so it means flip. I still have the base as negative 2, and it's being cubed because my negative exponent has already been dealt with. Negative 2 cubed is a negative number. Negative 2 times negative 2 times negative 2. So I have 1 over negative 8, or negative an eighth. 2/3 to the minus 4. Flip. 3's on the top, 2's on the bottom. With a positive 4. 81 over 16. Now I have negative 2 to the negative 2/3 to the negative 2. Okay, a negative exponent means flip. So I have 3 over negative 2 squared. So I've dealt with that guy, and I still have that guy, one step at a time. If you take 3 over negative 2 and you square both the top and the bottom, which is our power of a quotient rule, I have 9 on the top, 4 on the bottom, but I still have that pesky negative sign. So the question that I started with says you have a negative number, and that negative number is minus 2/3 to the minus 2, and we get minus 9/4. The next rule is for rational exponents where you have a fraction as your exponent. 4 to the 1/2 means square root of 4. We're used to writing a square root like that where we don't indicate that there's a little 2 there. That means I need two identical factors that would give me the answer 4. Well, you know what it is. The answer is 2. If I have 8 to the 1/3, it's the same principle. I am looking for the cubed root of 8. So the bottom of the fraction goes in the little house guy. Okay, I'm looking for 3 identical factors for 8. And for 8, it would be 2 times 2 times 2. And since I have 3 identical factors, my final answer is 2. Okay, a little more complicated. 256 to the 3/4. The 1/4 part of it tells me I have a root. So the base, the 4 means it's the 4th root of, and then the 3 says, but you're still raising it to the power of 3. And we can kind of deal with that later. It doesn't matter if you cube first and then take the 4th root, or take the 4th root and then cubed. That doesn't matter. The 4th root of 256 is 4. And then we'll cube it. 4 cubed is 64. So a general rule would be, if you have something to a rational exponent, you are taking the nth root and raising it to the mth power. I don't even know if that's a word. Okay, there's your rule. Let's just do a couple more. 16 to the 1/2. Halves are nice because we know square roots. So you can write it like that, or you can put the little 2. Answer is 4. 32 to the 1/5. Fifth root of 32. Notice these are all really pretty. I want something that when I multiply it by itself 5 times, I get 32. And just coincidentally, 2 times 2 times 2 times 2 times 2 is 32. 16 to the 3/4. The 4 means fourth root. Okay, that is not a puppy you hear in the background. I would never bring my puppy into school. That would not be good. All right, fourth root of 16 raised to a cube would be 2 cubed. Answer's 8. I just want to try a couple where we put some things together. For this one, we could solve by substituting the values first. Or we can use our rules of powers and then substitute the values. Let's try it both ways. So first of all, let's substitute the values and then solve. We have a to the 5th, which is 3 to the power of 5, times b cubed, which is 4, times c is a minus 2 to the power of 4, all over square root of, I know it's a square root of the whole thing because it's square root and then a set of brackets. I have a to the power of 4, which is 3 to the power of 4, times b squared, which is 4 squared. Okay, it's ugly, but we can do it. 3 to the 5th times 4 cubed times negative 2 to the 4. 2, 4, 8, 8, 3, 2. Yep, did that in my head. And on the bottom, I have the square root of 1296. Okay, and the square root of 1296, of course this is in my head, is 36. 248, 832 divided by 6, sorry, 36, is 6192. 6912. Another way we could do it, so if you're at a party and you don't have your calculator, I mean, we're still going to end up with a big number, but maybe we could simplify a little bit first. So if we have a to the 5th, b cubed, c to the power of 4, all over a to the power of 4, b to the power of 2, and I know that a square root means to the power of 1/2. I can simplify that bottom a little bit. So the top again, if I have power of a power of a product, I'm sorry, the exponents inside get multiplied by the half. So I have a, 4 times a half is 2. B, 2 times a half is 1. Now I have division. A to the 5th divided by a squared is a cubed. Subtract the exponents. B cubed divided by b to the 1 is b squared, and c to the 4th. Now it's still ugly, but it's more manageable. I'm going to substitute my values now. It would be 3 cubed times b squared times minus 2 to the power of 4. So I have 27 times 16 times 16 again. And of course, we all know that that's 6192. 2 to the x equals 64. Just as a little look at some things that we can do, if I know that 2 to the x equals 64, I can't solve that unless I have the same base, at least not yet. I know that 64 could be rewritten as 2 to the power of 6, so x must be equal to 6. If I know that 9 to the 2x minus 8 equals 3 to the 2x plus 5, I can't do anything with that unless they have the same base. My rules are all for powers with the same base. So I'm going to change that 9 to 3 squared. I know that's the same. 2x minus 8 equals 3 to the 2x plus 5. Now I have same bases, and I have power of a power on the left side, and I know what to do with that. We multiply the exponents with power of a power, so I'm going to have 4x minus 16 equals 3 to the 2x plus 5. If I have an equality with the same bases, the exponents would have to be the same. So 4x minus 16 is equal to 2x plus 5. And we just need to solve. Get all the x's on one side, all the numbers on the other. So I am going to subtract 2x from both sides. I am going to add 16 to both sides. And then I'm going to divide both sides by 2. And this once will let you do a decimal. All right, the next. 3 times 5 to the x equals 375. Well, at this point, I've got an annoying 3 there. You did not hear my puppy stuck on the rolly chair and unable to get off. All right, I would divide both sides by 3. So we've got 5x equals 125. Again, I can't solve that or do anything with it unless I have same base. I happen to know that 5 cubed equals 125. So x must be equal to 3. All right, now that you have all of your rules of powers, including rational and negative exponents, we have lots for you to try.